Waukesha Pumps, the leading producer of stainless steel positive displacement pumps for more than 5 decades. Manufactured in Waukesha, Wisconsin, and stocked locally by factory-trained distributors, Waukesha pumps are designed and built to meet the demanding needs of today's pump user. The Universal series of pumps is available in 6 sizes with a capacity range of 0.3 to 300 gallons per minute. Standard features include the Waukesha non-galling number 88 alloy rotor, a choice of seal options, precision helical timing gears, full flow ports, involute splines, and heavy-duty shafts, all providing extremely high volumetric efficiencies, 200 psi pressure capability, and a 2-time factory reconditioning program. During the next 20 minutes, proper care and handling procedures of the Universal series of pumps will be reviewed. By following these procedures, your Waukesha pumps will provide long, trouble-free service. Waukesha pumps are precision-made, and extremely close tolerances are maintained. Due to these close tolerances, great care must be taken when cleaning and handling the fluid head, which includes the cover, body, rotors, and seals. In the maintenance of pumps, it's important to recognize when parts are worn excessively. Detecting wear in the early stages will allow you to repair your pump with a minimum cost and downtime. Periodic cleaning and a simple look-feel inspection of your pump are recommended. Waukesha recommends changing the oil every 500 operating hours. The bearings must be greased every 250 operating hours. If the pump is installed where moisture and condensation are heavy, lubrication should be made more frequently. Excess grease will accumulate in the bearing housing and can be removed through the clean-out hole covered with the plastic plug. Before working on your Waukesha pump, shut off the power and lockout controls. In addition, isolation valves should be closed and the inlet discharge lines should be disconnected. Remove the wing nuts using a soft hammer to loosen them. Avoid using metal hammers, as this will result in damage to the pump parts. Next, remove the cover. If it's stuck, loosen it with a soft hammer, but do not use screwdrivers or other hard objects. When the cover is loose, remove it from the body studs. Place the cover on a rubber mat or face up on the floor or bench. This will help avoid nicks and scratches on the cover face. Remove the cover O-ring and discard. Use the rotor nut and rotor nut wrench to locate the rotors perpendicular to each other. The rotor timing should now be checked. Clearances on both sides, wingtip to wingtip, must be equal. Remove 2 rotor retaining nuts using the special wrench supplied with the pump and hit it sharply with a soft hammer to loosen the nuts. Use the remaining nut and wrench to orient the rotors perpendicular to each other, and remove the rotor with both wings exposed first. If the rotors cannot be removed by hand, use a soft hammer and tap on the ports of the body. Remove the rotors and body partway off the studs. Tap the body back. At this point, the rotors can usually be removed by hand or with a hard wood or plastic lever. Do not use a screwdriver or other hard objects. In extreme cases, a gear puller may be required. If so, apply the puller at the points indicated and use a mill file to remove all raised areas made by the puller. After removal, place the rotors on a rubber mat or place the rotors hub down to avoid damage to the rotor wings and hub outside diameter. Remove the pump body by pulling it straight off the body studs. Use a soft hammer and tap on the ports if the body is stuck. Again, place the body on a rubber mat. Use caution with mechanical seals and avoid dropping them. Check the rotor wings for indications of metal-to-metal contact. If this condition exists, the pump should be repaired or replaced. Generally, this contact is caused by either a twisted shaft or loose, worn, or mistimed gears. The rotor and shaft spline should be inspected for excessive wear and replaced if worn. Spline wear is commonly caused by a rotor running loose for extended periods. Check the rotor end which locks against the shaft shoulder and shaft shoulder for signs of wear. If this area is worn, A common cause may be extended running with a loose rotor retaining nut or daily disassembly and slamming the rotor in place on reassembly. If worn, it should be replaced, or the shaft should be re-shimmed to maintain the proper back face clearance. The bearing condition should be checked whenever the pump is disassembled. The bearings are failing and should be replaced when movement of either shaft can be detected at the interface of the shaft and the grease seal. Movement can be detected when hand loading the rotor end of the shaft to approximately 30 pounds of force. Gear backlash is excessive if there's any free movement when rotating either shaft without transmitting motion to the other shaft. Report this condition to the maintenance supervisor. As the wear on the gears is at 180 degrees, redo the backlash check 2 times at 60-degree intervals. Generally, the cause for excessive backlash is due to loose or worn gears. All fluid head parts should be cleaned and inspected. Raised nicks and scratches should be removed by using a mill file. The interfaces between the body and the bearing housing control the front and back face rotor clearances, and therefore need to be maintained in a clean and flat condition. Your Waukesha Universal Series pump will accept a variety of product seal arrangements. The single O-ring seal type is simple and inexpensive and is made up of 3 parts for each shaft: the shaft O-ring, body O-ring, and stainless steel sleeve. The body O-ring may be removed by using the special O-ring tool. The O-ring groove should now be checked for damage as well as product or foreign matter. Install a new O-ring as shown using an approved O-ring lubricant. After removal of the shaft O-ring, clean and inspect the shaft O-ring grooves. Apply O-ring lubricant and install a new O-ring in the shaft grooves, being careful not to cut the O-ring on the spline or shaft shoulder. Use the forward shaft O-ring groove when using the O-ring seal arrangement. The purpose of using this forward O-ring seal location is that it limits product migration under a limited portion of the sleeve. This facilitates easier disassembly of the sleeve on the next cleanup cycle. After cleaning both stainless steel sleeves, inspect for wear, nicks, and scratches. If worn excessively, the sleeve can be assembled to make use of 2 wear surfaces. Apply O-ring lubricants to the inside diameter of the sleeve and install on the shaft, being careful to engage the drive pin into the spaces in the sleeve. Rotating the sleeve until prongs engage against the drive pin will ensure proper assembly. The double O-ring seal arrangement is primarily the same, except a carrier is utilized to handle the second body O-ring. The carrier also has an O-ring to seal between the carrier and the body. Apply an O-ring lubricant to the O-rings and install in the carrier. Install the carrier on the body, being careful to engage the slot in the carrier onto the square pin in the pump body, forcing the carrier toward the pin, and then forcing the assembly straight down to ensure proper assembly. The Waukesha Universal Series of pumps also accepts single and double mechanical seals. The single mechanical seal consists of 5 components: shaft O-ring, body O-ring, wave spring, inner seal, and seal seat. All seal components must be handled with extreme care. Remove the seals from the body, clean and inspect them. Do not reuse if the seal face is scratched, chipped, or cracked. Remove the body O-ring and discard. Remove the seal seats and the shaft O-ring. The shaft O-ring should be replaced and the seat cleaned and inspected thoroughly. Do not reuse the seats if they're cracked, chipped, scratched, or grooved. Lubricate the new O-ring and install, taking care not to cut it while passing over sharp edges. Relubricate and install seal seats, being sure to line up the groove on the rear face with the drive pin on the shaft. Lubricate the face of the seat. Lubricate and insert new O-rings in the body grooves. Assemble the wave spring on the seal and install into the pump body, engaging the square pin located in the pump body. Again, lubricate the seal faces. The double mechanical seal consists of the single mechanical seal components with the addition of two added components: outer seal and O-ring. Apply lubricant to the new O-ring for this outer seal and assemble on the seals. Insert seal assembly into the body, engaging the notch with the pin, forcing the outer seal toward the pin in the body, and then forcing the assembly straight down. To assemble the liquid end of the pump, the body is placed over the shafts and studs, being careful that the seal components are not nicked or knocked out of place. Press the body firmly against the housing, engaging the dowels. Assemble the rotor onto the shaft, engaging the large spline tooth with a large groove in the rotor. Using a nut on this shaft and using the special wrench, rotate the shaft until the rotor wings are in a vertical position. Install the second rotor and secure both rotors using the double rotor retaining nuts. Each of the retaining nuts should be tightened using a special wrench and hitting the wrench handle sharply a few times with a soft hammer. In addition to the standard twin-blade rotor, Waukesha offers a single-blade rotor for use when pumping large particulates. Hold or secure the body in place against the bearing housing and check for proper rotor seating. The rotor wing must be below the body face and can be felt with the fingers or thumb. Install a new O-ring in the cover groove. Stretching of this O-ring often helps it to fit freely into the cover groove. Mount the cover on the studs and push it against the body, being sure the O-ring remains in the groove. Install the wing nuts to the studs and tap each nut with a soft hammer. Waukesha offers as a standard option relief covers and jacketed covers, used to maintain product temperatures. The second portion of this video presentation is intended to show the proper disassembly and reassembly of the bearing housing assembly. Remove the oil drain plug, drain oil, and discard the oil. Remove cap screws from the gear cover and remove the gear cover. If the cover sticks, use a soft hammer to loosen it. Remove and discard the gear cover gasket. Remove the oil seal from the cover and discard. Straighten the locking tabs of the lock washers. Prevent the shafts from turning by wedging a wooden block between the gears. Use a spanner wrench or drift to remove gear lock nuts. Protect the liquid end of the shafts by wrapping them with tape. Remove the front bearing retainer bolts and pull off the retainer and gaskets. If the retainer is stuck, leave it in place. It'll press out when the shaft is removed. Place the housing on an arbor press with the liquid end down. Use wooden blocks under the liquid end of the shaft to prevent it from falling. Place a wood or plastic block on the end of the shaft and press it out of the housing. The gears are now free to be removed. Remove the shims and identify them with the shaft on which they were used. Remove the O-ring, press it out, and discard the grease seal from the front bearing retainers. Press out and discard the rear grease seals in the housing. For 15, 30, 60, and 130 series pumps with bearing spacers, use a hydraulic press and V-blocks to remove the bearings and spacer from the shaft. For 60, 130, 220, and 320 series pumps without bearing spacers, remove the rear bearing using V-blocks and a hydraulic press. Secure the shaft assembly behind the lock nut in a soft-jawed vise. Remove the front bearing lock nut using a spanner wrench or drift. Remove the front bearing using V-blocks and a hydraulic press. Clean and inspect all parts thoroughly, which are to be reused. Coat the front bearing area of the shaft with Molykote grease. Place the shaft upright in a hydraulic press with the spline end down. Unwrap the front bearing assembly and place it over the shaft with the shield side up. Pressing on the inner race only, press it onto the shaft until seated against the shaft shoulder. Place the bearing spacer over the shaft onto the bearing. Coat the shaft rear bearing area with Molykote grease. Slip the rear bearing over the shaft with the shield side down. Pressing on the inner race only, press it onto the shaft until it seats against the spacer and front bearing. Place the shaft upright in a hydraulic press with the spline end down. Coat the front bearing area of the shaft with Molykote grease. Unwrap the front bearing assembly. Do not interchange parts of one bearing assembly with another. These parts are precisely matched in manufacture and must be installed as a matched assembly. All parts on both the front and back bearings are marked with a serial number. The front bearings also have an A and B side. All parts with the A following the serial number are to be assembled to the A side of the cup. Lift the cone and roller assembly out of the bearing stack and place it on the shaft with the large radius on the inside diameter of the cone down. Pressing on the cone only, press it onto the shaft until it's seated against the shaft shoulder. Place the spacer over the shaft on the bearing cone. Place the bearing cup over the cone and roller assembly, keeping the cup oriented with the proper roller assembly. Coat the remaining bearing cone and roller inside diameter with Molykote grease and slip them over the shaft with the large radius on the inside diameter of the cone up. Pressing on the cone only, press it onto the shaft and into the cup until the cone is seated against the spacer and the other cone assembly. For shafts with front bearing lock nuts, apply Molykote grease to the threaded area on the shaft and to the face of the lock nut. Install the spacer washer, lock washer, and lock nut finger tight. Clamp the shaft behind the lock nut in a soft-jawed vise and drive the lock nut tight using a spanner wrench or drift. Refer to Table 2 in the Operation and Maintenance Manual for tightening torque. Place the shaft upright in a hydraulic press with the spline end down. Slip on the grease retainer with the flange up. On the 320 series, install the spacer before the grease seal. Coat the shaft bearing area with Molykote grease. Unwrap the rear bearing assembly. Do not interchange parts of one bearing assembly with another. These parts are precisely matched in manufacture and must be installed as a matched assembly. Lift the cone and roller assembly out of the bearing stack and place it on the shaft with the large radius on the inside diameter of the cone down. Pressing on the cone only, press it onto the shaft until it's seated. Apply Molykote grease again. Slip the bearing cup over the roller assembly. Install both the inner and outer spacers. Place the remaining cup onto the outer spacer. Pressing on the cone only, press it onto the shaft until it's seated, making sure the outer spacer is concentric on the shaft. Place the bearing housing on an arbor press. For pumps without bearing spacers, install the front bearing grease seals with the lip toward the center of the cavity, flush with the back face of the bore. Coat the lip seals with microplate grease number 555. The next step involves shimming, which is a most critical step, and if done properly, will assure the correct front face and back face clearances for trouble-free operation. There are three basic methods of shimming. The first method is used when the existing old shaft is to be reused. By using the very same shims as were on the existing shaft and bearing assembly, it's highly likely that there will be no change in the shim thickness required, even if the front bearings are replaced. The second method is used when replacing the existing shaft with a new shaft. This method requires a precise measurement of the existing old shaft and bearing assembly from the rotor shoulder on the shaft to behind the last shim. This same measurement can be accomplished on the new shaft and bearing assembly by adding or subtracting shims. When this shimmed new shaft and bearing assembly is installed in the gear case, the correct or nearly correct front face and back face clearances can be expected. The last method is described in the Operation and Maintenance Manual and involves adding an estimated amount of shims per Table 3, also found in the Operation and Maintenance Manual. This method may require disassembly and reassembly to achieve the correct amount of shimming required. Install the shaft assemblies in the bearing housing with the spline end up and the drive shaft in proper location to give top or bottom drive as required. Using a sleeve to press against the outer race, press the shafts into the housing until seated against the shim pack. Grease the front and rear bearings through the grease fittings until the grease is visible around the ball or roller assemblies. Install the grease seals in the bearing retainers and coat the seal lip with microplate grease number 555. Secure the shaft assemblies in the housing with bearing retainers. Check to make sure there's clearance between the retainer and the housing. Install the pump body and rotors. Check the back face clearance. Refer to page 42 and Table 1 for the clearance required. Add or subtract shims as required to set the back face clearance. Remove the rotors and the body. Check the clearance between the bearing retainers and the bearing housing. Series 15 and 30 need 40 thousandths to 50 thousandths inch clearance. Series 60, 130, 220, and 320 need 15 thousandths to 40 thousandths inch clearance. Install shims between the bearing and retainer if required. Remove the bearing retainer and install a gasket or O-ring as required. Reinstall the bearing retainers. Install spacer seals and gear spacers. Coat the lip of the rear bearing seal. Press in the rear seals with the lip facing out. On Series 15, 30, 60, 130, and 320 pumps, the rear seal is pressed flush with the housing. On Series 220 pumps, the seal must not be flush. It must be 1/8 of an inch outside of the housing. Place the keys into the shaft key slot. Install the gear with the single punch mark onto the drive shaft and the gear with 2 punch marks onto the short shaft with the punch marks straddling the single mark of the drive gear. Apply Molykote grease to the threaded area on the shafts and to the face of the lock nuts. Slip on the lock washers and lock nuts. Tighten the lock nuts with a spanner wrench or drift. Refer to Table 2 for tightening torque. Bend the locking tabs to secure the lock nuts. Press a new grease seal into the gear cover. Place the gasket over the gear cover and mount the cover assembly over the shaft extension onto the bearing housing. Fill the gear cavity with microplate number 140 oil to the proper level. You are now part of the Waukesha Pumps tradition. By following these procedures, your Waukesha Pumps will provide long, trouble-free service.